In this video, we're going to do some practice problems relating to the derivatives of log functions and inverse trig functions. So first, just as we did in the previous video, let's show that the derivative of arc cosine is negative 1 over square root of 1 minus x squared. Let's kind of see where this comes from. And we will use the formula here that the derivative of the inverse function is 1 over the derivative of f of the inverse function. And note that in this case, our function f is cosine, so its derivative is negative sine. And our inverse function is arc cosine. So this formula, we should have the derivative of the inverse is equal to 1 over the derivative of the function, that's negative sine, of the inverse function arc cosine. And note that negative sine of arc cosine is not a nice thing to deal with, but we can use the Pythagorean theorem sine squared plus cosine squared equals 1 to simplify this. And in particular, we're going to write that sine squared equals 1 minus cosine squared, and sine is equal to square root of 1 minus cosine squared. So I'm going to replace sine of something with square root of 1 minus cosine squared of something. So I can write that the derivative of arc cosine is going to be equal to 1 over negative sine, but sine is going to be written as square root of 1 minus cosine squared of arc cosine. So we replace sine of something with square root of 1 minus cosine squared of something. Right, we're replacing x in this equation with arc cosine of x. Then note that we can simplify this cosine squared of arc cosine using the fact that those are inverse functions. Write this as just x squared, and we have our result that this is going to be 1 over negative square root of 1 minus x squared, or negative 1 over square root of 1 minus x squared. So we can use the formula given to us, but it really comes down to using the Pythagorean theorem to rewrite that expression into something nice. All right, now let's do some derivative problems using some other rules that we've learned in this chapter. When we're dealing with these big derivative problems, we're going to ask the question, should we use the product rule, the quotient rule, the chain rule, or is this just a straightforward derivative in the beginning? Is it multiplication of functions, division, or is it function composition? And in this first problem, this is function composition. We have the chain rule. The inside function is 2x squared plus 3x, and it is inside of natural log of something. So we are going to take the derivative of natural log, which is 1 over x, and that's going to be the derivative of the outside. We are going to leave the inside alone. And we're going to multiply by the derivative of the inside function. That is the chain rule, those three steps. So we can write this as the derivative of 2x squared plus 3x is 4x plus 3 all over 2x squared plus 3x. There is our derivative. All right, next, x squared arctangent of 2 square root of x. We need to ask ourselves, as a whole, is this product, quotient, or chain? And although we're going to have to use the chain rule at some point, this is a product rule question because I have two functions multiplied together, x squared times arctangent of 2 square root of x. So the product rule says that we are going to take the derivative of the first function times the second plus the first function times the derivative of the second. And note that the derivative of x squared is 2x. So we can write this as 2x arctangent of 2 square root of x plus x squared. And then we just need to take care of this derivative. And this is a new derivative that we're going to have to use the chain rule. So the chain rule says that we're going to find the inside function, which is 2 square root of x. The outside function is arctangent of something. So we need to find the derivative of the outside function. And note this is going to be 1 over 1 plus x squared. So we're going to have the derivative of the outside function, 1 over 1 plus something squared. We're going to leave the inside function alone, and we are going to multiply by the derivative of the inside function. And we have one more derivative to do. Note that's just a straightforward derivative, so we'll write our final answer now. We have 2x arctangent of 2 square root of x plus x squared. 1 over 1 plus 2 square root of x squared is going to be the same thing as 1 plus 2 squared, which is 4, square root of x squared, which is x, times this derivative. Note this is going to be the same thing as the derivative of 2x to the 1/2, which is 2 times 1/2 x to the negative 1/2. So we're going to write that as just x to the negative 1/2. We can cancel out those 2's. And there is our big derivative. So note that if we go step by step, we only have to do one derivative rule at a time. We may have to do 3 or 4 derivative rules in a problem, but just one at a time. If you're trying to do this all in one big step, it can get confusing and you can make errors that much easier. All right. Next problem, we have the derivative of 15 times arc sine of 9x over log base 2 of x. And note that we are going to use the quotient rule here because we have division of functions. So this derivative is going to be equal to, first of all, a 15 that comes along for the ride, and then the derivative of the top, that is arc sine of 9x, times the bottom log base 2x minus the top arc sine of 9x times the derivative of the bottom all over the bottom squared. So we have two more derivatives to do. Let's take care of the derivative of arc sine of 9x, and note that we have to use the chain rule there. We have the inside function is 9x, outside function is arc sine of something, and we know the derivative of arc sine is 1 over square root of 1 minus x squared. So writing this down, we're going to have the 15, and then in parentheses here, we're going to have the derivative of the outside, which is 1 over square root of 1 minus something squared. We're going to leave the inside function alone, 9x, and we're going to multiply by the derivative of 9x. Then we have log base 2 of x minus arc sine of 9x, and then times the derivative of log base 2 of x, which is going to be 1 over natural log of 2 times x. And all of this is over log base 2 of x squared. So one more derivative to take care of, that's the derivative of 9x. And we can write this as 15 times 1 over square root of 1 minus 9x squared in parentheses times the derivative of 9x, which is 9. All of that times log base 2 of x minus arc sine of 9x times 1 over natural log of 2x all over log base 2 of x squared. And there's obviously some simplification we could do there, but we're not going to do the simplification on these really difficult problems unless we need to. All right, one last problem, something kind of different, and this is going to be using the fact that the derivative of the inverse is 1 over the derivative of the function of the inverse. So based on this graph below, we want to find the derivative of g at 5. And we're given some information. We're given the function and the tangent line of f at x equals 5. So note that for this problem, we're calling g the derivative. So the derivative of g is going to be 1 over f prime of g of x. That's what we're doing here. So in order to find this, or I should say what we're looking for here is going to be the derivative at 5, which is going to be 1 over f prime of g of 5. All right, now we can kind of get into it. What is g of 5? So g of 5 is going to be the inverse of 5. So that's going to be the function value or I should say the x value associated with the function value equal to 5. And that's going to correspond to this point right here. So in this point, we have x equal to 3 and f of x equal to 5. So that means that the inverse, when x is equal to 5, the inverse is equal to 3. It's like we switch the roles of these things. We switch the x and the y. So here, the inverse of 5 is going to be equal to 3. So now we've boiled this problem down to 1 over f prime of 3. Now I realize I made a little mistake here. I called this line here the tangent line at x equals 5. It should be the tangent line of f of x at x equals 3. And that's the x value that we're talking about. And this is how we're going to find the derivative of 3. This is going to be the slope of the tangent line. So that slope is going to be the change in the y values over the change in the x values. That's going to be 4 over 2, which is 2. We get our answer of 1/2. So this problem is kind of weird, but it's showing that even with a little bit of information, we can get information about the derivative of the inverse. And it's kind of good practice dealing with derivatives and inverses together.